Hi, this is Mrs. Urechko, and this video is to accompany your study guide for adding and subtracting fractions to help you prepare for your test that's coming up on Tuesday, December 4th. So I want to go through the study guide with you and show you how we got the answers on the study guide. Not every single one, because I think we're pretty good with the ones that have the same denominator. But just go through a few examples and focus more on the ones with different denominators to help you out. So these ones here, we know life is good because our denominators are the same. This one here was just a little bit trickier because the answer was improper. So to turn this improper fraction into a mixed number, you should have this on your study guide. The numerator is divided by the denominator. So 9 divided by 7. I can take out of my 9, I can make one group of 7. 7 times 1 is 7. I subtract and get 2. So to turn that remainder into a fraction, the denominator I started with stays the same, and the numerator goes on top. So the addition part of this one was pretty easy, but my improper answer needed to be turned into a mixed number. To subtract with the same denominator, again, our denominators stay the same, and we just subtract our numerators. Mixed numbers are also the same. If the denominators are the same, you can continue to keep it written horizontally. Add your whole numbers to your whole numbers and your fractions to your fractions, and the denominator stays the same. To subtract, same thing. I subtract my whole numbers from my whole numbers and my fractions from my fractions, as long as this first fraction is bigger than the second fraction. If there's no fraction here, or if it's too small, you'd have to borrow from the whole number. So this one here has that being the case. I have a whole number, 7, minus 1 3/8. I don't have a fraction here to subtract the 3/8 from. So in that case, life is a little bit harder. So I would write that vertically. So I'm going to redo this one over here on a piece of notebook paper. It was 7 minus 1 3/8. I see I have no fraction to take the 3/8 from, so I'm going to have to borrow 1 from the whole number. So 7 goes down to 6, and the 1 that I took out, I'm going to make into a fraction. The fraction has to mean 1 whole to equal the one I took out here. And I could choose any fraction that means 1 whole. 4 over 4, 7 over 7, 9 over 9. Any fraction where the top and bottom are the same equals 1 whole. But I want the one that's going to make life easy and have the same denominator as this one here. So I'm going to choose 8 over 8. So 7 becomes 6 8/8. And then I can subtract. 6 minus 1 is 5. 8/8 minus 3/8 is 5/8. So the answer would be 5 5/8. So that pretty much covers everything that has the same denominator. But if the denominators are different, life is a little bit harder, and you can see there's a lot more work on this side. So when I'm looking at this part of my study guide, I notice that 1/4 plus 1/2 denominators were different. And so as soon as I see different denominators with adding and subtracting fractions, I need to rewrite that problem vertically. The same was the case here. When I had different denominators with a subtraction, I automatically rewrite the problem vertically. Okay? So let's work out this one on my notebook paper over here. 1/4 plus 1/2. I apologize if the phone is, if my video is a little shaky. I'm trying to hold the phone in my hand while I write. Okay, so I'm making these symbols and blanks over here because I need to find equivalent fractions that have the same denominator. I can't add fractions with different denominators. I can never just add up the denominators. So I have to make the denominators become the same. And the way that you change fractions into equivalent fractions is by multiplying each fraction by a fraction that means one whole. If we know that if we multiply a number by 1, we get the same number. If you multiply a fraction by 1, you get the same amount. Sometimes those fractions look different because we could multiply by a fraction that means one whole. So the numbers would be bigger, but it's still equal to the original amount. So I need to know what I'm going to multiply by. I don't know that until I know what I want to use for my new common denominator. So if I'm going to be multiplying, I'm going to end up with a multiple of 4 over here. And if I'm going to be multiplying here, I'm going to end up with a multiple of 2. So I need to look for a common multiple of both 4 and 2. 4 and 2 have lots of common multiples, but I don't just want any old common multiple. I want the least common multiple, the LCM. Because if I use a bigger multiple, then my fraction is going to end up being bigger than it needs to be. So I'm going to list the multiples of my two denominators, 4 and 2. The 4 multiples are 4, 8, 12, and so on. Multiples of 2 are 2 and 4. And I can continue on, but I don't need to go any further because I can see that the least common multiple is 4. And that brings up a good point. You should check your denominators and see if one is a multiple of the other. If it is, that will be your LCM. So you don't have to mess with listing the multiples if you already can tell that one of your denominators will work. So that means this fraction would not change. I would just put in 1 over 1 right here. This fraction is going to change. 1/2 times something equals some fourths. So I have to ask myself, 2 times what equals 4? And that answer is 2. And so if I put a 2 here, I need to put a 2 here so that this fraction means one whole. It doesn't change the value of this fraction. Then I need my new numerator. 1 times 2 is 2. And then I can add, now that my denominators are the same. 1/4 plus 2/4 is 3/4. Okay? Now I can see over here on my study guide that subtraction works the same way. I have my problem rewritten vertically. I looked for the least common multiple of my two denominators and found that to be 20. So my least common multiple becomes my new common denominator. Then I ask myself, 4 times what is 20? And I found out that was 5. So 5 goes on top, and I multiply to get the new numerator. And then I asked myself, 10 times what equals 20? And that was 2. So I put 2 above. 7 times 2 equals 14. Once my fractions now have the same denominator, I can subtract them. Be careful when you get to the final step. Some students continue to add every single one at the end, even though this one is a subtraction problem. So we have to subtract the numerators instead of add. But everything else is the same. We have to find a least common multiple and use it as a new common denominator. With mixed numbers, we have a similar process. The only difference is that we're going to ignore those whole numbers until we get to the end, convert our fractions to equivalent fractions, and then add our whole numbers and our whole numbers and our fractions to our fractions at the end. For subtraction, same thing. I looked for the least common multiple of my two denominators and found that it was 15. I converted my fractions and then subtracted my whole numbers and my fractions at the end. Some students are still having just a little bit of trouble with this step right here. So I just want to show you one or two more examples of how to complete a pair of equivalent fractions. So let's say I have the fraction 2/3, and I need to turn it into an equivalent fraction with a denominator of 24. Maybe I found a least common multiple of some pairs of fractions, and my least common multiple is 24. So that means I've got to multiply this fraction to make 24ths. So I ask myself, 3 times what equals 24? And that answer is 8. And in order for this to be an equal fraction, I have to multiply the numerator by the same number. Because remember, this fraction here must equal 1. 2 times 8 is 16. So 2/3 is equal to 16 24ths. Okay? I'd like to do one more practice problem like that. So let's say I need to turn 3/5 into an equal fraction with a denominator of 20. My paper wants to move around. So I have to ask myself, 5 times what equals 20? And I can use a multiplication chart to help me. It's just like a division fact. 5 times what is 20 is the same thing as 20 divided by 5. When you're looking for a missing factor, you're really dividing. And the answer to that is 4. So I put a 4 here so that this fraction equals 1 whole, and then I multiply across to get the numerator. Okay? I'd like to do one more practice problem. Let's make it an addition. So let's add 5/6 plus 4/9. 5/6 plus 4/9. I have different denominators, so I'm going to rewrite that vertically. I'm going to have to make equivalent. Oh, my light turned off. Hold on. There we go. That motion sensor. Sometimes if I'm sitting at my desk, it just shuts the light off. Before I can add, I'm going to have to get those denominators to be the same. So I'm going to look for the least common multiple. Hopefully, you're doing this problem too on a sheet of notebook paper as I do it. So I'm going to give you time to think about how you find the least common multiple. Hopefully, you remembered that we write down both denominators and we list the numbers we get when we multiply these numbers. 6, 12, 18, 24. I think I already know the least common multiple because I know my multiples of 9. 9 times 2 is 18, and that was on my list for 6. So my least common multiple is 18, and it becomes my new common denominator. If you're solving this on your own, I want you to think about the next step. How will we complete these equivalent fractions? You don't have enough information to complete this and this, but you do have enough information to find out what goes here by asking yourself 9 times what equals 18. And the answer to that is 2. So a 2 goes above, and I multiply across to turn 4/9 into 8/18. Up here, 6 times what equals 18, and that is a 3. So a 3 goes here, and I multiply across. 5 times 3 is 15. So now I have equivalent fractions with the same denominator. I'm going to add my numerators. 15 plus 8 is 23. And my denominator stays the same, and that is 18. And now you should be saying, uh-oh, that's an improper fraction, and we don't want to leave our answer that way. So we're going to divide our numerator by the denominator. It looks like it's going to be tricky division, but if I think about 18 and 23, they're pretty close together. So 18 is only going to go into 23 one time. 18 times 1 is 18. I subtract and get 5. So the answer is 1 and 5/18. Hopefully this was helpful to you. Please study your study guide. Sorry this is kind of a long video, but you're welcome to fast forward through the parts that are most helpful to you. And I wish you the best of luck on Tuesday's test. Thanks for watching.